4.7, piecewise functions. So a piecewise function is a function defined by two or more equations, and each piece of the function applies to a different part of its domain. So thinking about that, let me just rewrite this. This will be f of x equals, and then we have this little squiggly line there to say that it splits it up into two. We'll have x minus 2 if x is less than or equal to 0, and then we'll have 2x plus 1 if x is greater than 0. So what this does is it breaks up this function f over its domain. So we have the top part of it, that's for x less than or equal to 0, and the bottom part of it for x greater than 0. Both of these are lines, and then the graph here is for this function. Let's look at it. So x minus 2, if x is less than or equal to 0, that would be the left side of it. There's that line, right? It has a slope of 1 and a y-intercept of negative 2. But once it gets up to 0, we have a closed circle, right, because less than or equal to, and we have to go to the other equation, the blue equation. This one has a slope of 2 and a y-intercept of 1. It says if x is greater than 0, not greater than or equal to, just greater than. So we have an open circle on its edge, right, down 0, and then it continues the function with a slope of 2. Right, so it kind of breaks it up there. A step function is a piecewise function defined by a constant value over each part of its domain. If you'd like to look more at that, it's on page 230 in the book, but generally its graph is going to look something like this, like little steps. Kind of neat. You should look up that in the book. Example 13, let me see if I can copy that one down nicer. This says f of x equals 4x plus 3 if x is less than 1, and x plus 7 if x is greater than or equal to 1. So there's our function f, and it says to evaluate it when x is 1 and when x is 0. So looking here, we'd have f of 1, that's whenever I plug in 1. Before I plug in, I have to decide, am I going to plug into the top part or the bottom part? 1 would belong to this one because it says x is greater than or equal to 1. So I plug into that bottom piece and it'll be 1 plus 7 equals 8. I do the same thing for f of 0. This time I'm going to plug it into the top one, and I'll have 4 times 0 plus 3, which is 3. All right, scrolling down, example 14. We're going to graph a function and describe its domain and range. So let me copy this down correctly. It should say y equals negative 2x plus 4 if x is less than or equal to 1, and x minus 1 if x is greater than 1. And of course, we had the little squiggly line there. All right, so we're going to graph that and describe its domain and range. First off, I guess I need to draw a little graph here. Now I know that it's going to have a break or a jump or something. Something's going to change at 1. So what I'm going to do is I'm going to draw a little dotted line at x equals 1 to remind me that there's going to be something interesting that happens at the graph there. To the left of that, this is x is less than 1, and to the right of it, it's x is greater than 1. So on the left side of the graph, I'm going to use this equation, the top equation there. So let me see if I can get any more space in this. There we go. There. So I would have an intercept of 4, 1, 2, 3, 4, and it has a slope of -2, so I'll go down 2 and over 1, and I'm hitting that red line whenever I go there. It says x is less than or equal to 1 in my equation, so I can have a closed circle on that. Now that I have 2 points, I can go ahead and sketch my little graph there, and it would be like that. Now I need to go on to the other side of it. I'll color it blue just to remind us. So this is x minus 1. Well, for starters, let's see, what would that line be like on the red line? So I need to plug in 1 into that, and I'd have 1 minus 1 equals 0. So I'm going to have an open circle at the point 1, 0. So there's my open circle. This has a slope of 1, so I'm going to go up 1 over 1, up 1 over 1, and I can draw a little arrow there. Right? So if I just looked at this yellow highlighted part, it would look like the equation that I've highlighted yellow. If I just looked at the blue part, it would look like the equation that I highlighted blue. Together, it makes the piecewise function. It makes it that has a little jump there. All right, let's look at another one. We're going to write the piecewise function for the graph. This one's actually an absolute value graph, right? So we could describe an absolute value graph a little bit differently. I'll start off by saying, well, f of x equals, draw my squiggly lines. So let's start off by looking at this piece there. This looks like the line y equals -x plus 3. So in my function here, I'm going to say, well, -x plus 3. And where does it stop? It would stop right here, which is x equals 3. So I'll say for x less than or equal to 3. On the right side, this would be, I meant to highlight that. That would be the line y equals x minus 3. Right? If you can continue this down, it would end up touching down there at -3. So this would be x minus 3. And again, it butts up at x equals 3. So I'm going to have an x into 3. It's greater than 3. And these actually butt up to each other, and there's a closed circle there. So it doesn't really matter which one I decide goes with x equals 3. I just have to pick. Because I already put less than or equals on the first one, I have to leave it as just a plain old greater than, right? If you were doing this on your own and you had answered like this with the or equals to on the bottom, that would also be good, right? It doesn't matter which one it goes with. Most of the time, I will give it to the top one, or the one that I guess is more to the left on the graph. All right, example 15 again. Is this supposed to be example 16 maybe? Write a piecewise function for the graph. This left piece would be y equals, well, it has a slope of 2, so 2x, and an intercept of -1. And this piece up here would be y equals 4. So putting that together, I'd have f of x equals, the left piece is 2x minus 1, and the right piece is just plain old 4. Looking at the left piece, I'll highlight it yellow. It has a closed circle on x equals 2, so I'll say that this is x is less than or equal to 2. And then looking at the other one, I'll highlight it blue, has an open circle on x equals 2. So this is going to be x is greater than 2. And that's it. All right. Make sure that you have these two examples. That would be good to look at for your homework. And also this one too would be a good one to look at for the homework. All right, that's all.